Okay, this lesson we'll be talking about the roadbed moduli, or another way of saying that is the natural soil strength, and all the things that it might affect it. So let's take a look at this system here. Now, this is a flexible pavement system. So when we're dealing with flexible pavements or asphalt concrete, we know that it is a layered system, and therefore every layer depends on the one beneath it to sustain and maintain its strength over time. That means that this subgrade right here is a very important one, because if this one is weak, then the other layers above it would have to be over designed or designed to withstand a higher load, which would ultimately turn up turn out to mean more money. And so, what is a subgrade? Natural question someone might have. Well, a subgrade is another way of saying, the natural soil that is excavated and brought to or transported to a location. And that natural soil is going to be compacted and prepared for all of the other layers and base courses to be put on top of it. This top layer is where our wheels touch. Okay, and so the load that is placed on the road by the wheel is felt most by this surface layer. Well, that means that if we were to guess which layer had to be the stiffest, all right, the strongest, we would probably guess it'll be this top layer, right? And the way that we can uh, measure or speak about the stiffness of each layer is use a term called the modulus of resilience, or the resilient modulus. Sometimes you might see me write it, or you might see it be written in this form. Okay, resilient modulus. And again, it's a way of determining or saying how stiff the road is, or that layer is. You may think of the resilient modulus as being almost similar to the modulus of elasticity, where that represents the the ability for that layer or that thing to resist a load such that it will not deform it. So these two are pretty similar to one another. Now, as I said before, that your modulus of resilience increases as you work your way up the layered system. So this will probably have the highest modulus of resilience. And it's not uncommon to see a modulus of resilient moduli or modulus at the top layer equal to, I don't know, somewhere around 150, say 1,000 psi. Not uncommon. But down here, again, is what really is important, because this determines everything else. So now you see that the resilient modulus differs by layer, which also would mean that the resilient modulus would differ by pavement type. And so the uh, resilient modulus of an asphalt design would be different than, say, one for a concrete design up here at the top. So not only does the modulus of resilience, or the resilient modulus, differ by type of surface, but it also will differ by the weather pattern, especially as it relates to the natural soil, because you can get rain, you can get water down here, they can have freeze-thaw cycles, and all of that can occur, and therefore it would affect what the actual stiffness is during a certain season. So if you will humor me, I have drawn a couple of things here to represent those seasons. Now, I love fall weather. Um, it's nice, it's comfortable, nothing really too dramatic is happening, and therefore our soil is probably going to be okay. So I'm just going to go ahead and put my Modulus of resilience here as the base here in the fall. We just assuming that. But in the winter time, it can get really cold, and sometimes it can even get down to a negative, degree, a negative 15 degrees, or it can get even 15 degrees, or um, 32 degrees. As long as it's frozen, what's going to happen to this soil is you probably have a modulus of resilience because it is frozen that is going to be a little bit higher than normal, right? A little bit stiffer here. And then you have that frozen soil eventually thaws out, it warms up, and now we're in the springtime. Okay, in the springtime, you have a lot of wet weather. Okay, so now that modulus of resilience, or the stiffness of that soil, is going to actually decrease. You got water, wet. And then you move over to the summertime, it's pretty hot, and therefore that modulus of resilience may increase, it may decrease. It could go either way because it kind of rains in the summer too. And so now, which one of these are you going to pick for your design? Well, you can't just pick one. You have to account for everything and all the changes in the season. But every time there's a change, there is something that we call a relative damage that occurs to the soil. And that relative damage is usually represented by this variable, and that variable has the following formula. So that is raised to the negative 2.32. And I wanted to make sure that I kind of put that in red so that you can see. So that's relative damage, and that takes into account all of the changes that occurs over time through seasons, so that when we design, we can design with a resilient modulus that is appropriate and takes all of the seasons and changes in weather into account, so that our modulus of resilience, when we design for it, is not overkill or is not under design. Therefore, everything else on top of it would be properly designed.